pollution, darkness, global warming, uncertainty in power sector. That's what we have got from the last few years of the conventional power sector. Now, the time has come for the new dawn, for the green, balanced, certain power sector. A very good afternoon to one and all. Here we are to express our views on new avenues in renewable energy. We'll let you know about what exactly the new avenues are working throughout the globe and in our country. Myself, Rohit Bhutani, and he's Karunesh Dubey in the team New Dawn. So to study something, we need to have a structure first. So first, what we did, we structurized how to study new avenues in the power sector. But first, we'll be letting you know what exactly the need for the renewable energy. Then what are the present avenues in the renewable energy. These are wind, solar, small hydro, biomass. All of us know about this, so I won't be discussing about them. I will be discussing only the new avenues. In the new avenues, I have divided them into two parts. First is new avenues in renewable energy under implementation by MNRE. That's being implemented only in India. That's our biomass, hydrogen, battery operated vehicles, chemical energy, geothermal and tidal. And the other one is new renewable energy under R&D throughout the globe and also in our country. Biosolar, liquid nitrogen, man-made photosynthesis, MRC, cytosol, superpower. This will be discussed by Karunesh Dubey only. So, why we need renewable energy? Actually, to save environment, to save the scarcity of fossil fuels, to save energy security, for sustainable and all-round development of the India and throughout the globe. So here, I invite Karunesh Dubey to lead you further towards the sector that's being under R&D. So, Karunesh, can you take it forward?
Thank you. The first technology is biosolar power plant, that is green solar cell. The key component of photosynthesis is photosystem 1, which is harnessed from the blue-green algae. It is bioengineered to interact with the semiconductor. It is then used in the green solar cell. Basically, green solar cell is basically of two parts. First one is biological and second one is non-biological part. Biological part consists of these PSI particles and non-biological part consists of small tube made of zinc oxides. These tubes are specifically bioengineered to attract the PSI particles. Now, the two materials intimately intermingle on the metal oxide interface. When illuminated by the sunlight, PSI excites and electron jumps into the zinc oxide semiconductor, thereby producing an electricity. The prototype of this technology has been made by Massachusetts Institute of Technology. Now, second technology is liquid nitrogen engine. A liquid nitrogen economy is a hypothetical proposal for the future economy. In this liquid nitrogen engine, liquid nitrogen is heated into the heat exchanger. It extracts heat from the ambient air. Liquid thus gets converted into the gas. The expansion ratio is around 1:694, and thus engine or rotary engine is worked out. Now, human-made photosynthesis. These are the technologies for that. Now, first one is turbocharging photosynthesis. The objective of this technology is to enhance the potential of the photosynthesis by focusing on an enzyme called rubisco. By improving the photosynthetic efficiency, would increase in the agriculture productivity, which in turn will lead to the production of food and renewable energy. This is artificial leaf. It does not resemble with the natural leaf, but it is fashioned from the silicon and catalyst like nickel. When it is placed in a single gallon of water within bright sunlight, this device splits water into the hydrogen and oxygen. Oxygen gets liberated into the atmosphere while hydrogen is trapped further, and it can be further utilized in the hydrogen cell. The prototype is already been made by MIT. Now, second is capturing wasted solar energy. The cyanobacteria is a bacteria which can absorb much more solar energy than it can utilize. The name of this technology is to couple the photosynthetic operators in one bacterial species to fuel producing metabolism of the second species. The connection could be provided through the hair-like electrically conductivity filaments called pili, which are generated by some bacteria. Thus, two biological systems are working together to make fuel from the sun's energy. Now, microbial reverse electrodialysis cell. This technology is the combination of two technologies. This microbial fuel cells and reverse electrodialysis. This is microbial fuel cell. It generates the electricity with the help of bacteria and the water, while this is RED technology. This works on the salinity difference between the water, like fresh water and the seawater. It generates electricity through that. The problem is with this technology, it can create, it doesn't, large number of RED stacks are required to produce the huge amount of electricity. But with the help of this exoelectrogenic bacteria, the number of RED stacks required to produce an electricity can be reduced. So this is the test cell of MRC. Now stratospheric superbugs. These are the superbugs which are found in the stratosphere of Earth. These are considered to be the highly efficient generator of the electricity. With the help of this, an artificial biofilm is created, which doubles the electrical output of MFC cell, which I have discussed earlier, from 105 watt per cubic meter to 200 watt per cubic meter. The prototype has been made by Marine Biotechnology at Newcastle University. Although these are some of the technology which are under research and development, these are not commercial viable yet, but soon they will be commercial viable. Now Rohit will tell you about the technologies which are being implemented. Thank you.
Thank you, Ganesh. Now we know what are the trends that are being followed under R&D throughout the globe. Now we'll be discussing what exactly MNR is following up in the country so that the new avenues in the renewable energy can be boosted up. So I'll be telling you not the technology, but just only how the MNR is implementing in the country. First is biomass. For the biomass, we have biomass gasification is an appropriate technology for cogeneration. It's already been used in the sugar mills and in the rice mills. You can see over there 10 megawatt plant in the Maharashtra and the other 30 megawatt plant in the Maharashtra, one from the rice mill and another from the sugar mill. MNR is also establishing protocols, but the main drawback with the biomass is we still have 94% of the potential that is available in the country being unutilized. That is where MNR is focusing on. 5% of the available potential has been already connected to the grid, and 1% is being utilized as an independent source, being in the rural areas and also somewhere in the for the captive power plant generation. The other one is hydrogen power generation. The hydrogen is a clean substitute to fossil fuels. MNRE supports R&D on various aspects of hydrogen energy and production storage used as a fuel for generation of mechanical, thermal and electric energy. There are various ongoing projects in the hydrogen field. Some application you can see over there, the hydrogen generator being already been developed by MNRE as a prototype. Now you can see that these three pictures in the downside, hydrogen can be used in the as a transport fuel. Already in 2008, we have established with the help of IOCL and MNRE collaboration, we have formed a hydrogen CNG pump in New Delhi itself. It's a big achievement for MNRE. Next is the battery operated vehicle. We all know one battery operated vehicle, that's REVA. MNRE is promoting R&D of BOV under alternative fuel for surface transportation program. The R&D is being done by institutes like CEC, RCI, NCL, CMET, etc. And we have a research going on high density, low discharge rate hydrogen cells. Next is the chemical energy. The main program that's going on by the MNRE is for this is chemical sources of energy program. Hydrogen is the primary fuel for all the fuel cells. A 10 kilowatt. There are two prototypes being developed. By MNRE. These are 3 kilowatt PEMC based UPS, and the second is 1 into 3 kilowatt PMFC based stacks. The next is geothermal energy. Geothermal energy is already available in abundance in the country, so it needs to be tapped out, and it can be used for the power generation, for direct heat application, for space heating, greenhouse, cultivation, cooking, etc. These are the various provenances available in the country that needs to be tapped. The next is the tidal energy. Tidal energy has already been developed for the commercial scale. A 3.75 megawatt plant has been under execution by NHPC under the guidance of MNRE, and Gujarat has already formed SPV to sponsor and study for the large scale exploitation of tidal energy across the coastline of Gujarat. This is the way we can harness tidal energy. Last but not the least is MNRE programs, and then what we recommend is our recommendation is to follow MNRE programs, invest in R&D of hydrogen, avoid conventional sources of production if renewable energy utilization is possible. Thank you.
Thank you, Rohit.